Good evening, ladies and gentlemen. My name is Padilla. I'm the Dowh Hole Tools, and tonight I want to kind of take a chance to explain to you guys what a Dowh Hole motor is, what it does, and how it works. You guys are drilling engineers. Since this is a drilling engineer conference, I kind of want to take a chance to really explain to you how the motors work. I know that you're hit up 20, 30 times a month by drilling salesmen, and so I wanted to make sure that you could really understand what goes into a Dowh Hole motor. Even if you don't pick Dowh Hole Tools as your motor company, I feel like it's very important that you at least know what goes into a drilling motor. So the first thing I want to explain is where it belongs when drilling oil and gas well. It belongs on what's called a BHA, or a bottom hole assembly. The bottom hole assembly consists of your drill bit, your motor, which is on top of that, and then you've got all your extra tools like stabilizers, reamers, agitators, stuff that you'll learn about from other salesmen, but I want to explain what the motor does. The motor goes on top of the drill bit. The drill bit is at the very bottom of the hole, and the motor is the backbone. It's what powers that. In the past, a lot of companies have used just the rotary table, which is at the very top of the rig. It just turns, but it's a very slow, methodical process. And so to speed that up, a lot of companies start developing these motors. Now, what goes into a motor? A lot of people ask me, okay, where's the exhaust on this motor? And how does it all fit into a long tube? And that was the same question that I asked when I first started at Toro. Where's the exhaust? How does this thing work if it's just in one small skinny tube? And so when I got to my first day at my job as a motor salesman, they broke it down and showed me, and it's very simple. The very top of the motor is the top sub, and that's where you actually hook it up to the rest of the drill string, to your stabilizers, to your drill pipe, to all that stuff. Below the top sub is what's called your power section. This is the meat and potatoes of the motor. It's got a rotor and a stator. The rotor basically looks like a rototiller that you've seen in a garden. The stator is a big, long metal piece of pipe with rubber inside of it that fits the rotor. And so in this stator, it makes a tight fit. That rotor and stator makes a really tight fit. There's not much room, but there's a little bit of motion that can be made whenever mud is pumped down there. So they pump hundreds of gallons per minute. Our motors are rated for anywhere from 0 to 900 gallons per minute of mud that flows through these motors. And it creates this pressure. When that pressure is created, it goes down to what's called our bearing section. What that does is that takes this eccentric motion that this rotor and stator is making, and it centers it all into one powerful concentric motion. It goes down and it's focusing into this, what's called our drive line, or our coupling shaft. Just like any other car, it's a coupling shaft that's got joints on each end, and it takes all of that crazy motion and it puts it into one powerful motion, which then goes into our drill bit, to our bit box, and that's what turns the motor. So that kind of gives you a basic understanding. A lot of these times you'll hear salesmen say, well, we have hard rubber, or we have standard rubber. So now you know, when they're saying that, they're telling you how hard the rubber in their stator is. And that's important because the hardness of your rubber is going to tell you how much differential pressure you can create. I'm sure as engineers, you've seen a lot of companies talk about how much differential pressure they want to get. That's important because pressure equals torque. And so the more torque you have, just like if you're drilling something at home, you're pushing on something, you're creating torque, you're getting through that wood or that metal faster because you've got more pressure. So that's what our motor does. We offer hard rubber and standard rubber. And so when you have that hard rubber, it allows you to drill faster and harder. Something else that I want to talk about today is you as engineers, when you're picking a motor, what do you have to consider? Like I mentioned a minute ago, you have to consider the rubber. Do you want hard or do you want standard rubber? You have to also decide, whenever you're picking that bearing section, we offer adjustable bend housings and we offer fixed bend housings. You've got to pick what degree you want. It goes anywhere from 0 to 3 degrees. And so you've got to know as an engineer, and you'll obviously know this, but you've got to decide what your bend needs to be, because when you're drilling that curve in that oil and gas well, you've got to have that certain bend. And so I also want to explain how an oil well is drilled. We have vertical wells, and we also have directional wells and horizontal wells. As I mentioned, having that bend, that allows you to drill those directional wells. How it works is you start off with a vertical section, you hit a curve, and then you go horizontally. So having that correct bend in mind is very important, because then you know your build rates and how fast you're going to build that angle to drill that. Maybe you're drilling a 5,000 foot well, or maybe you're drilling a 15,000 foot well. And so That's the main consideration when drilling a directional well, is knowing what bend you want. Your vertical, you're not going to need a bend. It's just a straight, it's what we call a straight hole motor. So that, and then you want to know what size stabilizer you're going to have. Normally it's about half an inch smaller than what your actual hole size is. So if you're drilling a 17.5-inch hole, you want a 17-inch stabilizer. The last thing that you want to decide is this going to be water-based or is this going to be an oil-based well? It's very important for us to know that because we set those fits. Your rotor and your stator are set to a certain fit. If you're running oil, it's going to make that stator, that rubber in that stator, expand and push against that rotor. If it's too tight, it's going to seize up just like anything else, and you're going to have a failed motor. So we want to make sure that we have the right fit, so we need to know, do you want oil-based or water-based? And the last thing that I want to cover is just any kind of questions that you guys might have, because a lot of times, like I said, people don't know what they're getting into. We come and ask them these questions and they say, well, maybe I just need, I don't know, I think I'm using oil base. Oh, I don't know, just give me a 1.76 degree bend. So as engineers, I would say really dig in, find out, do your well planning, find out what you're going to need, and ask your salesman, what kind of stator rubber do you guys have? What kind of metal do you use in your motors? And find out how well built that motor is. So now I'm going to go ahead and offer some free time. Any open questions that you might have about our motors or anybody's motors, just let me know, and we'll answer them. Thanks.